look at Jupiter coming in and out of focus as the atmospheric waves compress and decompress overhead. Jupiter isn't quite culminating yet, and yet the scope decided it wanted to orient west to see it. It's now 7:33 p.m. Pacific Daylight Savings Time on the 28th of March, 2026. And I'll let Jupiter run for a couple of minutes. You know what features to look for. We're not going to see the great red spot. It's going to be another 12 days from the 22nd. So that would be like the 3rd of April before it should cycle back in, and complementary rotation to our own 24-hour cycle. Jupiter has a 9-hour, 56-minute cycle. I'm liking the contrast on the equatorial belts. The northern and southern temperate belts, south to the left, and in this case, south would be to the right, because we're looking west, and north to the left. They're coming in and out of focus. It seems to have a bit of a pattern to the cycle. Maybe every second or so it cycles in, cycles out. It almost looks to me as though the equatorial region is starting to reveal, along with the equatorial belts, some micro-level detail. I think I'm going to brighten the image up just a wee bit from the standard setting of 1.0. Let's see what it does to our... There we go. I pushed it up to 1.1. I think it ranges. Let me see what it ranges to. Ranges all the way up to 2 and down to 0. And there, I've made it disappear. Anyway, we'll go back to 1.1. Fairly sharp image, but earlier I didn't use the contrast, display contrast, to adjust the image, and I do believe it helps a bit. So, micro level details, we already covered the macros, the two south and north equatorial, south and north temperates. We see a reduction. Ooh, there may actually be a lunar, a Ganymedian a lunar shadow on the moon. It seems to be revealing itself. Now, we can determine where the satellites are and how many of them are available. We can go with up in terms of display contrast. No, that isn't bringing it up. I'm going to have to change the exposure time. Let me do that. So pushing it all the way up. No, we are not seeing it, but there's 3 ranges on this. Let's bring it back to here. Let's try the gain. Let's see if the gain will reveal them. Oh yeah, they're starting to reveal, but not particularly good. There seems to be only one, wow, only one of the Galilean satellites is visible. Let's push it back down and get back to our view. So it's entirely possible there is a Galilean satellite transiting across Jupiter. And it'll be very interesting to push up the magnification. Let's do this so we can count how many matrix bars it appears in. Also notice it seems to be visible on the northern equatorial belt to the left. Well, we can't get any better resolution than 1 arc second. I've basically determined that in a previous video. So, but I do believe when I have it seen through a fine 6-inch scope optically at high power, I have seen what appears to be an actual dark, resolved vision of the shadow of a Galilean satellite on Jupiter. So that was a nice find. Now, if we look to the right, to the southern belt, for some reason, we seem to be getting a better view of white ovals sprinkling south of the south equatorial belt. Now, that could be anomalous because I do believe I saw them in the past associated with the belt to the right too, although I'll have to check the videos. Magnification may be a little bit high, and let's drop it right back down to 300% e-zoom, where we originally saw the Galilean satellite. So with that, we're now about 5 minutes in. I don't want to push this one too long. Let's say that on the 28th of March, 2026, we were able to watch a Galilean satellite, probably Ganymede because it has the largest shadow, or actually saw the, actually, no, it would be reflecting sunlight, but this is definitely the shadow of a Galilean on the northern equatorial belt of Jupiter's disk at 450x using a Rev 2 system on a 150 millimeter, 40% obstructed fast Newtonian telescope. And with that, I'm going to say carpe noctem.